Hello everyone, this is Dr. Sergey Sarkisov and we are going to continue with the law of cosines. Okay, what we're going to do with it now is we're going to apply it to a specific example that I think is really cool. So look, you have a triangle, okay, ABC, okay, this is the law of cosines by the way, remember. Cosine angle C is equal to a squared plus b squared minus c squared all over 2ab. In other words, cosine of an angle, we just did this recently, okay, cosine of some angle like this, cosine angle C, is equal to the two adjacent sides, the two touching sides, a squared and then plus b squared, okay, minus the opposite side c squared all over 2ab, okay. Again, cosine of this angle is equal to this squared plus this squared minus this squared all over 2 womp womp, okay? So let's remember that and let's look at this triangle. It's a really cool case where let's say we are looking for finding angle C or angle, let's do angle B, okay? Let's do that one. So let's say you're looking for angle B. Now you have to think of it from the other direction, right? So if cosine angle C, remember, let's write all these. If cosine angle C, let's do this marker here, was equal to, okay, the two touching sides, remember, a squared plus b squared, summation of those squares, minus opposite side squared, c squared, all over 2 times the product of the touching sides, ab, well, then similarly, okay, we can do cosine angle b. Okay? Cosine angle b would be very similar, but you have to do, now the touching sides are a and c, so it's a squared plus c squared minus b squared all over 2ac. Well, let's see what happens when we apply our numbers. So equals to, a is root 3 minus 1. Okay, what a weird number, but let's try it. And this is a non-calculator problem. Imagine you're given this an exam without a calculator. What do you do to solve this triangle, right? How do you find those angles, in other words, that make this happen? So we have this, and then we squared, a squared. What was c? C is a root, what is that? A 2, so plus a 2 squared. Okay, then we're going to do minus a, what? A root 6 squared, which is going to be 6, right? Root 6 squared, all over this weird 2 times the, what? The a, root 3 minus 1 times the c, which is a 2. Okay, and that's equal to, let's be careful with this computation, okay, just to simplify a little bit, and we're going to actually get a good result. So look, root 3 squared is 3 minus a root 3 minus root 3, that's a minus 2 root 3, we're squaring a binomial, okay, plus a 1, that's all from there, okay, 2 squared, so plus a 4, and then minus a 6, right, root 6 squared, all over, what is that, 4 times root 3 minus a 1, okay, let's further this with the 3 plus 1 is 4 plus 4 is 8 minus 6, so that's 2 left, minus a 2 root 3, okay, all over, what is that, 4, and then root 3 minus 1. Okay, let's cancel 2's, and we have 1 minus a root 3 is equal to 2 root 3 minus 1. Now look, the root 3 minus 1's cancel, only it's a negative, and you get a negative 1 over 2. Now, cosine of what angle is a negative 1/2, especially in a triangle? The only option we have for an angle between 0 and 180 degrees, that's cosine of it, is a negative 1/2. If you do cosine inverse button, you'll get this actually on a calculator, okay? Cosine inverse of negative 1/2. We know that, it's 120 degrees. It's in quadrant 2. It's kind of going to the left. It's a negative number, but it's, the reference angle is 60 degrees. We know cosine of 60 is 1/2, and cosine of then 120, okay, degrees is going to be, or 2 pi over 3 radians. But so cosine of 120 degrees is negative 1/2. So cosine, so angle B is going to be cosine, or arc, let me write arc cosine of this negative 1/2. And we know without a calculator, okay, that's the cool thing about this, that it's 120 degrees. Wow, we have shown something. We've found some kind of angle. And you know what you can do? You can do now law of sines if you like. Okay, you really can. So for example, let's do law of sines on angle A. Okay, remember law of sines. So you can do law of cosines all 3 times if you like. I don't recommend that. I recommend law of cosines once. Okay, so let me put LOC here. Okay, that's the first application we did. Let me actually lower that. So we started it here. Okay, this is where we started the problem. We were looking for angle B. And then let's do law of sines. If you remember what it is, hopefully, it's not a bad, it's easier to prove than law of cosines that we did just recently. But look, remember, sine of angle A over little a is equal to sine of angle B, right? Over little b, over the side length b, over sine of the angle C over the side length opposite of it, C, okay? And let's specifically find angle maybe A, okay? Let's see, what in the world is angle A gonna be, right? Okay. So angle A, here's what's gonna happen, okay? Angle A, we're gonna do this with, we now know angle B, so let's do this, okay? Right there. Sine of what we don't know, let's do this in a different color now. Let's see, let's do like one of these, okay? So sine of the angle we do not know, angle A, it would be nice to find it, right? That's the goal. Over A, what was A again? It was root 3 minus 1. Yeah, and then the B was 120, and remember we found this, let's put it actually in red here, that's a 120 degrees. But we found that, it wasn't given initially, okay? So sine of angle A over little a, which is root 3 minus 1. Again, such an interesting number that we actually, with it, we were able to get some cool result, right? That is exactly 120 degrees for angle B. So what's sine of 120 degrees? Let's do that. Sine of 120 degrees. And that's actually, if you think about it, that's what? That's exactly root 3 over 2. And then what's B? B is root 6, right? So over square root of 6. Okay, and that's going to equal to, look, root 3 over 2 over root 6. If you simplify this, multiply top and bottom by, let's say, root 6 if you like. You can do that, it's fine. And 2 at the bottom, so look, let's multiply by 2 over root 6 over 2 over root 6. What happens? Root 6 becomes a 6, so it's going to be this. The 2's cancel on the top. Root 3 times the root 6. Actually, let's just multiply by 2 times the root 6, be easier, right? 2 root 6 over 2 root 6. That's easier that way for some students to see. So you get 2's cancel, root 3 times root 6, root 18. I'm going to hurry this up with a 3 root 2, a 9 comes out. All over, what is that? 2 times a 6, that's 12. Okay. Right? That's going to be, what? Root 2 over 4. Okay. And then that's going to equal to sine angle A over root 3 minus 1. So sine angle A, let's see what that is equal to root 3 minus 1 times that, which is going to be now root 6 minus a root 2, if you think about it, multiply it out, over 4. And anybody know what this angle is? Anybody know? It's actually, if you do, okay, you may know this, it's actually 15 degrees. But if you don't, what can you do? If it's 15 degrees, what can you do if you don't know it's 15 degrees? Well, you could have done the other one first, and you could see what that would have been, maybe 45 degrees, and that's easier. But let's say you didn't see that. You're like, all right, well, if you do the sine alpha minus beta formula, let's say 45 minus 30 degrees, you would get that sine of 15 degrees, okay, is equal to, and I'm just going to put sine minus 1 button, okay, because I know a lot of us don't know this, but sine inverse of this root 6 minus root 2 all over 4 is actually 15 degrees exactly, okay? But let's say, again, I was saying calculate a problem. Let's say you're like, I don't know what this is. Then you kind of, let's say the blue was something we did, like we didn't do, or we decided, you know what, I still don't know. Let me try angle C instead, okay? That's my recommendation. If you can't finish this up and this is a calculated problem, there's something you can do about it, okay? Try something else, that some other number, because, maybe angle C can be found without a calculator. So try angle C, sine angle C over C, which is what? I think it's 2, right? Let's check it out. I think it's 2 up there, right? Okay. Yeah. Is equal to, let's do again, sine angle B. Okay, over B, and we did that already. Sine 120 degrees over B is what? That was what is that? I think a root 6, was it? Root 6. And so we do get what? Remember we did get root 2 over 4 up there. Remember? Right here. See? Let me show you root 2 over 4 for this. This was going to be eventually simplified that. Root 2 over 4. Okay, these are going to be nice numbers. Watch. Root 2 over 4. Because now, if I multiply top and bottom by root 6, if I cross multiply left and right sides by root 6, what is that happening? By a 2, sorry. Sine angle C, get rid of the 2 there, is going to be a 2 root 2 over 4, which is just a root 2 over 2. And guess what? Maybe some of you could have seen it already. Angle C, right away, we know what that is. Do arc sine of what? arc sine of root 2 over 2, what's the angle that gives us that for the triangle? 45 degrees. Okay, so let's say you did law of sines. Okay, that was like this is kind of like it didn't work. All right, so let's just pretend the blue didn't work. So law of sines, but we're still trying law of sines, and we get, so now we have 45 degrees for this angle C, because we can really, angle A, maybe you can see that that was a 15. Then what happens? Angle A, right? Let's finish this up with angle A. Let's do like a orange, okay? Well, how do you do with angle A? I usually say sum of angles. Sum of angles equals 180 degrees, right? In a triangle. So what you do is you say, you know what? Angle A plus angle B plus angle C, the measures are 180 degrees. Now, that means angle A is equal to 180 degrees minus angle B minus angle C, measures of those, which is 180 degrees, minus the 120 degrees, minus a what? 45 degrees, and that's exactly 180 minus 165, 15 degrees. We got this number, right, as well. And that's true with what we had here if you had a calculator, if you knew what that was. All right, and then that would have been 15 degrees. We have solved our triangle, and these are cool numbers, right? You can give this to somebody else. If you want an interesting recommendation for another triangle, that would be kind of fun. Try a 2, root 6, and a root 3 plus, but a plus here, plus 1 triangle. Okay. But so we have actually here an obtuse triangle. 120 degrees is bigger than 90. And you see, when you have a cosine and you have a negative, then it's just an obtuse angle then, right? Because you can do that. It happens. If a sine was ever negative, and it happens with like a SSA case, okay, called also the ambiguous case of triangle solving, okay, what happens is then you actually have no triangle works. You have an error in the calculator when you put a arc sine button on a negative number for a triangle. Sorry, a number bigger than 1. I mean, bigger than 1. Negative number would be weird too, right? Because you can't have a negative, degrees for, it would give you something, but it'd be negative, and you can't have a negative angle in a triangle, right? So it wouldn't work. Or like an angle that's bigger than 180, that also wouldn't work. Okay? So there we go, some ideas there for you. Hope this was helpful, and also hopefully this was somewhat enjoyable. All right, thank you.